So we are given an E versus X graph, and then you're supposed to find an expression for V in terms of X. Yeah, everybody remembers a little bit. And here is your which was like rho x1. Yeah, so we're given this and we want to find an expression for voltage in terms of X. That was the main problem. And then part B was show that your two expressions give the same value for V at X equals 0. Right? So, okay, I think I saw what people did on their homework, so I think everybody realized that you have to break this up into two parts. The voltage is going to have a different expression for when the field is like that, and it's going to have a different expression for when the field is like that. And then the key idea was basically relationships between E and V, right? And E dx. V is equal to negative integral of the field versus X. So we would integrate in two parts to get an expression for V. So for the first part, I can find an expression for this line, right? What I need is the slope, which is rise over run. So the rise is negative E max, and the run is a positive x1, right? So that's my slope, and slope times x plus your y-intercept, which is negative here, so that becomes 1. That's your E. Yeah. Let's call it that. So to find my voltage difference for this, my potential difference for this part, I would integrate that expression times dx, right? It's going to be a potential difference of V at some x between negative x1 and 0 minus this V at negative x1. Does that make sense? Right? This x here, it's between negative x1 and 0. And yes, please ask questions in between if you like, because that will be good. So yeah, does this make sense that integrating this would give me the difference of these two potentials? Yes? Okay, so let's go ahead and integrate that. Negative sign. My limits are going to be what I wrote down. So it's going to be negative x1 x. Yeah, and then we integrate that, so those negative signs just become positive because of that. So it becomes E max x plus E max x and minus. So I went ahead and put my limits in. Is that clear how we got there? I integrated and put in the limits, sorry. Is that okay? I can explain how I got here. So Yeah. Explain it?
Yeah.
Okay. So integrating this gives E max x squared over 2. I integrate that with respect to x plus. So did this make sense that these negative signs became positive? So that's what I get integrating it just in terms of, and then I have to evaluate it at these two limits, right? So then I plug in x, and then I subtract plugging in x1. Sorry, negative x1. So this becomes, I can change that. Yeah? Okay. Now here we get some cancellation. So this becomes E max x squared. So this becomes then 1x1 got cancelled, so this goes away. Yeah. So that gives me a negative E max times x1 over 2. Right? It's this minus half of that. So inside I get a negative E max x1 over 2, then that negative becomes positive here. Yeah? So that's my expression for the potential difference. Yes? This is V at some x less than 0 minus V at negative x1. Right? So what we were asked for was just this. So we'll take this to the other side, and we were given that we can assume, in the question we were told that you can assume that the voltage here is 0. So when you take 0 to the other side, it won't make a difference. So this just is your Vx, right? This becomes, this is 0. So that just becomes your Vx for x less than 0 and more than or equal to x1, negative x1. Okay, so that's half of the problem. So moving on to the second part, so now we have to find an expression for V for this part of the electric field. So for that we find an expression for that line again, right? So that is a positive slope. Rise is your E max over a positive run. So that's your positive slope, and then negative intercept. Yeah. So that's my E, right? Yeah.
Why is it a positive Emax for this? Oh,
so rise is 0, your y value here, which is 0 minus Emax. That's your rise, and then your run is going to be from x1 minus 0. So that gives you that slope. So now if I integrate this expression, it's again going to give me a potential difference between my final point and my initial point. So if I want an expression in terms of x, again I'll choose an arbitrary x value ranging between 0 and positive x1. Is that making sense? Yeah. So I'm going to start at 0 and then go to any arbitrary x less than or equal to x1. So that's important to realize. When I looked at people's solutions, I think it was hard to understand that integrating this doesn't give me the expression for voltage. for the expression that it's asking for, it gives you a potential difference between your final point and your initial point. So that's what we are going to do. So we'll be getting something like a v of x minus my v at 0.
That was something that I missed on this problem.
Okay.
And it resulted in not adding something at the end.
Yeah.
Can you explain why you're going from 0 to x on the right side, but negative x to x on the opposite side?
So here when you're integrating, whenever you're integrating e, you're getting a potential difference between 2 points, right? So you look at your final minus initial. So if you want an expression in terms of x, you say that I'm going to keep my final point less than 0, but it's going to be an arbitrary x that I'm going to.
Okay.
Okay?
Yeah.
Yeah? Does that?
I mean, I did it in my problem because Melody told me, but I the reasoning escaped me. So thank you.
But does that make it clear? Like I'm choosing this as my initial point, and then I'm going to an arbitrary x less than 0. And I mean, that less than 0 part, it seems like I'm just slipping it in, but it actually becomes what we are doing because you're just integrating this line.
And then on the right side, we're also just going to an arbitrary x.
Yeah, but then your initial point changes. Your initial point is v at 0 and not at
I see.
x1.
Okay.
Yeah?
Yeah.
Okay. So this is what this is going to give us, integrating that part. So over here it was easy because my v at negative x1 was just 0. But that I can't assume about v of 0, right? But I did something here that would give me v of 0. I found an expression for any arbitrary x ranging from negative x1 to 0. So I can just plug in x equals 0 here and get that. Does that make sense? Yeah. So when we integrate this expression, it's going to give me that potential difference, right? But I don't have v of 0 with me. Over here, when we got a potential difference, we were finding v of negative x1. So we were finding v of x minus v of negative x1, and we just said that v of negative x1 is 0. So this expression gives me my v of x on the left side. But here, the difference, we can't say that we don't know yet what v of 0 is. But I found an expression which gives me the potential at any point ranging from negative x1 to x equals 0, right? So I can just plug in x equals 0 in this expression that I found to get my v of 0.
So you would just have...
Could we do that right now?
You would just be left with E max x1 over 2.
Yeah, so this goes away, right?
The first two would cancel.
And that goes away. So v of 0 becomes...
Yeah, that's
where should I write it? Okay, I'll just write it here in a box. V of 0 becomes just E max x1 over 2, right? Does everybody agree? Yes? Okay. So we'll go ahead and integrate this expression, which, so negative of and this is going to range from 0 to x, the same limits. And that gives me negative E max x squared over x. And then that becomes plus. Yeah? And then this, so the 0 part will just make this 0. So I'm just So this just stays that expression. The negative sign. So this is my expression for this potential difference. Now what we were asked for was just that, right? And then so I'll just take that to the other side, which is adding. So I'll be adding v of 0 to that expression, right? To get just this. So I'll have E max negative E max plus E max x plus E max x1 over 2. This is your v of x for, and just subscript these. So we get that expression. Now, sorry, I forgot to mention at the beginning, we also have to draw a graph for v of x. So the way you can think about it is at the beginning you can, we did some problems in class where we were looking at e of x, e versus x graphs and making v versus x from them. So if you have an e versus x, so what is most helpful usually is that you draw a roughish graph of v versus x looking at e versus x, and then when you get these expressions you can check whether your graph matches that or doesn't match it, then you change it accordingly. So I have this e of x, e versus x. And I want to get a v versus x. So e is the slope, negative slope of v, right? E equal to negative dv dx. Yes? So what is happening to the slope of v as I move from negative x1 to 0 x1?
It's going kind of like a parabola.
Yeah, and what is the slope doing basically? So this axis is giving me the value of the slope of v, right? So what is happening to the value of e as I move from this x to that x? What is happening? It's decreasing. It's becoming more and more negative, right?
Yeah.
And what is the negative of this?
So
Am I saying something wrong?
No, you're saying think
Okay.
about magnitudes.
Yeah. So it's becoming more and more negative, but its magnitude is growing, right?
Yeah.
And I want to look at the negative of that. So my v is going to be the positive part, right? So my e is increasing, so the magnitude of my e is increasing, so my slope of v is increasing.
Yeah.
Does that make sense? You could rewrite this as dv. I think that might make it clearer. So slope of v is increasing, right? Because here my e is becoming more and more negative, so negative of that is it's becoming more and more positive. So it's going to be a parabola, yes, and it's going to be a slope that increases, right? And it starts at 0. The slope starts at 0, right? The value of e for this negative x1 is 0. And then what happens after that? When I get to x equals 0,
It's like an inflection point.
yeah, and what is happening to e now?
Are you sure that this slope is like a parabola, but like the other way?
So that way,
Just
what
like-
is happening to the slope of that graph? My
It's
slope
getting
is going to be
Less.
yeah. So my slope is decreasing for that parabola, right? Which is not what is happening with my graph, with my e versus x. So after after I cross x equals 0, what is happening to my e values? It's decreasing in magnitude. It starts from a big magnitude and goes to all the way to 0, right? So what would a parabola doing that look like?
So at first it'd be really steep and then it'd start
Yeah.
being shallower, I guess?
Yeah, exactly like that. What Molly suggested earlier, right? So it becomes something like that. Yeah. And we actually can say something about that value of v, right? Was it something we did that would give us v at x equals 0?
Oh yeah, isn't that term that we added, E max x1 over 2?
Exactly, yeah. So, and we already did part B, kind of. We verified. We didn't do part B. So yeah, we will get to that. So you get value of V at 0, and then I think we can move on to part B, or we should analyze our expressions and see if that matches what we did. So this is an expression for a parabola which has what kind of curvature? We are looking at this part. Do people know how to tell the curvature from an expression like that for parabolas? No? Yes. How would you do that?
Well, it's harder to explain now that you called them.
Yeah.
No, that's okay. As long as it's fine. So you look at the coefficient of x squared. If it's negative, you have something that's curving down, and if it's positive, that was when we were calculating v of 0. So when you look at it, when you look at the coefficient of x squared, if it's positive, you have something that's curved up. Okay? So that's exactly what we got, right? We got a curved up parabola from x1 to 0, negative x1 to 0, and we got a curved down parabola from 0 to x1. Yeah? So our graph matches that kind of analysis, and then we have to do part B, figuring out that both of these expressions give the same thing at x equals 0. So x equals 0 here would give us that. We did that, right? And then plugging in x equals 0 here takes that away, and it takes that away, leaves us with that. So it gives you the same expression.
Cool.
Okay, I think that was all that, yeah.
Cool.
But I think, mostly it was important to realize that integrating would give you a potential difference, and you had to find the second part here and take that to the other side, and then you would get an expression. For yeah.
I wasn't understanding the V at 0 part.
Yeah, that's what
The
I
issue.
missed.
Yeah,
Okay.
because I had the
Yeah.
rest of that, and
Mhm.
when it came to the second part, I got stuck.
Yeah, I think that was what happened throughout, because people really did well on finding the expressions that you had to integrate, but the problems came when you had to find limits. So when you had to think about the limits on those integrals, and when you had to do that stuff on the right hand side.
Well, I think that would happen if you because the first time I did this, I integrated from negative x sub 1 to 0,
Right.
and then from 0 to x1,
Yeah.
and you ended up with an expression without x in it.
That's true. That happens. That would give you the potential difference at a point.
Yeah.
It wouldn't give you an expression that changes with
Right.
that.
Cool. Thank you.
Yeah.